All right, good morning, everybody. My name is Rob Reich. I'm a faculty member here at the university. I teach political philosophy in the political science department. I have an appointment here at the Institute for Human-Centered AI, where we're sitting. And perhaps completely appropriate for the day's events, my own degree, PhD, is from the Graduate School of Education. I was a sixth grade teacher before I went to graduate school. So the topic of AI in education is something I'm keenly interested in. I'm going to introduce the panel in just a second, but I want to share something following Dean Schwartz about my own experience at the Graduate School of Education now 25 years ago, apropos the conversation today. So, number one, anyone who thinks about various questions about American education knows immediately that it is an unbelievably fragmented or decentralized or localized system, which makes the adoption of any new innovation across the entire system incredibly fraught. An historian of education I took courses with 25 years ago at the Graduate School of Education named Larry Cuban said frequently in classes that the last innovation adopted at scale and that's persisted over the course of decades in American education is the blackboard and chalk. And the enormous promise of artificial intelligence to revolutionize, enhance education, accelerate learning, teaching and learning offers us great promise, also some peril, which we'll talk about today. And I'm really curious to try to learn more about the various ways in which not merely we can find demonstration projects that are incredibly important, but also ways to navigate the fragmented policy and governance system of American education, including, of course, higher education at the same time. So with that as a brief introduction to the opening panel, I want to introduce our speakers. First is Percy Liang, a colleague of mine here at the Institute for Human-Centered AI. He directs the Center for Research on Foundation Models and a professor in the computer science department. Noah Goodman, who is a professor at Stanford as well in the Department of Psychology and in the Department of Computer Science, and Dora Dembski, I'm a professor in the Graduate School of Education. We're going to do short presentations from each, and then a moderated discussion with some questions from the audience as well. Thanks for joining us. And Percy, why don't you kick us off if you're willing?
Okay. I thought I was going third, but I guess I'll go first.
We can reorder on the fly if you want.
Yeah,
good, great.
Let me just pull up my notes. So I'm going to try to do this without slides because I've been inspired by philosophers such as Rob, who are so effective, and I'm sure you'll see a lot of slides, but we'll see how it goes. So as Rob mentioned, I'm the director of the Center for Research on Foundation Models, and I used to have to explain what a foundation model is, and now I could just say ChatGPT, and I think everyone understands what I mean by that. So the center started 2 years ago. And when we realized there was about to be a seismic shift in the way that these models are going to have a huge impact on our society, we assembled a fantastic team, including Rob and many others, 30 faculty across 10 different departments from computer science, law, philosophy, education, economics, and so on. And since then, we've been really interested in understanding and exploring all the different facets of foundation models. So what exactly is a foundation model? So ChatGPT is one example. DALL-E is another example that some of you might have played with on the image side. But more generally, a foundation model is a model that's trained at immense scale on internet scale data. So for example, a language model is trained to predict the next word given a previous word. So it's basically doing Mad Libs. For example, Stanford University was founded in blank. And if you complete the sentence, so the neural network is trying to do this over and over again. And in the process, it actually learns a lot about language, about reasoning and knowledge, and learns abstractions, not just superficial correlations. And what can these models do? So that's the thing that's really interesting, is that these models are emergent. So that you can't predict what they're going to do. Only after you train them, you start basically talking to them, you realize that it can do much more than we initially thought. And so, in fact, they're actually very general purpose engines that can be adapted to a wide range of downstream tasks, answering questions, summarizing documents, writing emails, generating poetry, and so on. So if you play with ChatGPT, you kind of get the sense of what I'm talking about. Okay, so that's the context of foundation models, which is the backdrop. And now I want to explore its ramifications on education. So I'm not an education researcher, although I aspire to be one, maybe one day. But I do teach, so I'm an educator. So I spend a lot of time thinking about what to teach and how to teach it to my students. And so I'm going to talk about how we teach, how foundation models can change how we teach, and also what we teach. And the mental model you should have is that we have these models, and they're always present, whether it be night or day. They're fast. They can generate a whole document in just a few seconds. They absorb broad knowledge from the internet. And finally, at present, they're still unreliable. So it has a very tenuous grasp of what truth is and maybe limited social awareness, although these things will perhaps improve over time. So that's something to keep in mind as we explore how the interaction between education and foundation models will happen. Okay, so how we teach. So there's students and there's teachers, and I think foundation models can be useful for both. So on the student side, the bread and butter of these models is the ability to answer questions. So sort of an obvious place where these can apply. The student is trying to learn about something. They want to ask questions. A foundation model can deliver an answer in probably a very succinct and specific way. You can ask follow-up questions because these are conversational and so on. But remember, these models are unreliable. So the answer might be right or wrong. So I don't think this is a fundamental issue in the sense that many other sources, talking to your peers, even teachers, I've been wrong sometimes using the internet. Everything has a source of, there's errors everywhere. And I think the key thing is to manage expectations and know when you're using a tool, what can you trust and what you can't trust. And part of that is the onus on the user, and part of that is onus on the model developer. The second thing I think is maybe more fundamental is that when you're answering a question, all these models have been trained to basically deliver the most accurate answer as fast as possible. And this is clearly not the same as delivering the answer that would enhance student learning. So you want some more pedagogically based reward system. I think this is an interesting and fascinating research question, although the existing models are not optimized for this. But there's no fundamental reason I think this can't be done. Besides answering questions, models can also ask questions. So ideally, you want the model to ask the right type of questions, not too easy, not too hard, based on the student's response. The model can maybe give feedback and give hints. And of course, this has to be done in a pedagogically sane way. So on the teacher side, I think there's some interesting parallels. So one thing that I think is really fascinating and maybe more immediate is the ability to simulate students. So you can imagine a model behaving like a student that answers or asks questions and simulates student confusions and different motivation levels. You have it. And this could be useful for teacher training to test out different teacher strategies. It could also be useful for students because the best way to learn something might be to teach it to someone else. And here, unreliability is maybe not as big of an issue because students are learning something and they're not certainly can't be expected to know everything. So maybe for now, this is like kind of a good place to start. A second application is generating problems. So I spend a lot of time when I'm teaching generating problems, starting with a core idea and then creating some context that's somewhat realistic around it. And one could imagine having problems generated automatically or at least assisting me in generating a problem, both in terms of kind of the skin, like whether it's about Harry Potter or football or whatever, and also, but maybe more substantively, the type of situation that's being presented given a core idea. And here we're really tapping into the generative creative capabilities of these models, that it's able to generate an infinite set of possibilities given appropriate prompt. A third thing where foundation models could be helpful is for assessment and providing feedback. So grading is important, but it's probably the least scalable part of the whole enterprise. But it's again very important. These models aren't reliable enough, so I wouldn't want these models just to automatically give a grade and then that grade be determining whether someone gets a job or not. I don't think maybe this is quite there, but I think a lot of cases are routine, right? If anyone who's a TA for a class knows that you kind of see the same thing over and over again. So a model could perhaps cover those and flag the interesting cases for a human or teacher to look at. And providing feedback, I think, is maybe even more interesting than just grading, because providing, looking at a student response, suggesting things to study, explaining why they might be confused, sending even motivational messages of some sort. This is all sort of within scope. Okay, so we talked about how we teach. What about what we teach? So I think there's this kind of growing fear that foundation models will just do everything, and why bother learn if you can just ask a model to not just multiply numbers but to even code. And I think if we look historically, the set of technologies from calculators for arithmetic, Wolfram Alpha for solving calculus problems, spell checkers, even Stack Overflow, I think really help people do tasks faster and maybe lessen the need to develop proficiency at some underlying skill. Not to mention the slide rule that Dan mentioned earlier. So my personal take on this is that I still think students should learn everything about how the world works, bottom up, from first principles, but understand enough just on the principles. But they don't need to be proficient. I think there's a difference between understanding in principle how to multiply large numbers from actually being able to do it really quickly. You don't need to do that, but you need to know the former. And after you've kind of understand something in principle, now if a foundation model is able to just do that for you, then great, you move on to the next thing. And I think maybe a fundamental belief I have is there's always a next thing. We'll never run out of things to learn and teach. So for example, instead of learning how to write code line by line, maybe you should focus on writing good specifications and tests, which is what people should be doing anyway when they're testing, writing code. Or instead of just focusing on the word by word essay, developing kind of ideas in the form of an outline or something. I think there's many possibilities that if you can get the basic level of skills sort of automated in some sense for you, then there's much more you can do. But one thing that's interesting is now the type of work that you're doing shifts a little bit more to kind of oversight and quality control, right? And this already happens in management, right? You have let's say programmers, and then you have team leads, managers, executives, and it's not like the people at the top have nothing to do. There's skill, a tremendous amount of skill there, but the skill is very different than what it is at the lowest level. And importantly, there's an element of responsibility. At each point in time, a person should be responsible for what they or their AI or their direct reports are producing. So in terms of skills, I think that using foundation models like ChatGPT is going to be an integral skill. In fact, there's already, I think Ethan Mollick, who is this professor from Wharton, actually has a class where he mandates the use of ChatGPT rather than prohibits it. I think, like I said before, oversight and thinking about quality control is going to be a much more important skill than just focusing on generating the answer. And then finally, adaptability is incredibly important, more than so than ever, because these technologies are evolving over time. And there's no one thing, narrow thing that I think is quote unquote safe, as if you, in the sense that if you learn it, then you'll be able to do it, because if it's sort of repetitive, then it can be automated. So I think the meta skill that we should, students should be really focusing on sort of general problem-solving skills and adaptivity. Okay, so just to wrap up, I think overall, I'm really excited and optimistic about foundation models and their role in human learning and education. They can ask questions, answer questions, generate problems, simulate students, provide feedback in a very context-specific way. The technology does have to improve. It has to get more reliable and more pedagogical. And there's a lot of work to be done, and a lot of people are trying to make this technology better. I think it's interesting to discuss, and maybe we'll have a little bit of chance to dive more deeply into it. What will we teach? So I believe strongly in still teaching the fundamentals, and I think we can do it better. But we have to go also beyond that to higher levels of skills like ideation and oversight. And the final thing is that it's really important, I think, when we're having these conversations to think about where things are headed, right? So 5 years ago, we could barely generate fluent text. And then we had GPT-3 in 2020, which showed that these models are extremely multi-purpose. And then we have ChatGPT only 2 years later. I guess that's maybe 2 months ago. And then this year, supposedly GPT-4 is supposed to come out, and it's going to be another big change. Who knows? But I think that there's just this progression. So I think when we're thinking about how to think about foundation models in the role of education, it's important to look at the trajectory so that we're not always playing a catch up. But I think it's a really exciting time, and I look forward to discussing this more with you. Thanks.
Thanks. Hi, everyone. I'm very humbled to be on this panel. When I first got invited, I had the gut reaction of, oh my God, although I have many projects in this space, I still feel like I'm not an expert in generative AI and I'm still learning. But I decided to adopt a growth mindset and take the challenge of just taking this opportunity to imagine what generative AI could do, and also raise awareness of one important application which I have been working towards. Specifically, how we can use generative models to empower teachers. As I think Dan and also Percy pointed out, now generative AI has kind of become synonymous with ChatGPT to most people. And when it comes to education, most of the newspapers and headlines have been about how ChatGPT is going to change student writing and how it's going to raise issues with respect to plagiarism or other things like the college essay, and how teachers need to transform the way they teach writing to begin with. But what a lot of these discussions that focus on student writing have overlooked is another important application, which is how we can use ChatGPT to support teachers directly. And this relates to realizing that actually most of the language that happens through instruction is not in student writing, but instead it's in the teacher-student discourse. It's the conversations in which teachers mediate knowledge and many other things to students. So for example, and this image was generated by DALL-E, I see that some other people were doing the same. As I mentioned, it is a medium for new knowledge. It is a vehicle for creating, fostering a culture of curiosity with Jennifer Lange-Ursuna. I don't know if she's here, but it's her research that shows that depending on the type of talk moves and discourse that the teachers use, they can foster a culture in which students are really excited to learn. And that is really like the basis and the conditions under which learning can happen, to adapt Dan's words. Teacher-student discourse also can help students adopt different mindsets. Like my colleague David Yeager has shown through various studies, several Nature papers, that just a very brief intervention to students and teachers around synergistic mindsets, which is a combination of growth mindset and stress can be enhancing mindset, that shows that when that students can embrace stress as an opportunity for growth and learn, and not see it as a negative thing that hinders their learning. It can have a lot of positive outcomes, even 10 years down the line. And related to the conditions of learning, one thing that Dan mentioned is many students don't have the same access to learning opportunities. And that is rooted in the classroom environment oftentimes. So if students don't feel like they belong, they don't feel like this is a place where they should be or where they can learn, no learning is going to take place. And that's, again, mostly on the teacher to create a culture in which every student feels like they belong. And in all of these areas, we know that classroom discourse is important in many ways, there's a lot of room for improvement for teachers. Through the many data sets that I've looked at on student-teacher interactions, I found that on average, 80 and 90% of the talk is dominated by the teachers. And also, I'm working with my colleague David on trying to use generative AI to help teachers translate what they're saying to growth mindset and trying to identify good examples from what teachers have said. It's extremely difficult to find language in teacher talk that's growth mindset supportive. In another project where we're trying to analyze different types of classroom management practices, differentiating punitive versus disciplining practices, we found that teachers use punitive disciplining practices 35% of the time, and disproportionately so in classrooms with more African American students. And related to equity, lots of social psychology research has shown that African American and Latinx students feel much less like they belong in the classroom than white students. So this is not to say that teachers are bad. It's the opposite, that they have a very important role to play, and there's a lot of room for them to grow, like for each of us in our job. And if they had the tools and the skills to grow, and then they could transform their students' lives. So how do we empower teachers, the experts who know their students best, the experts who know their material best in what they already do? Most of the conventional ways of training teachers or giving them feedback and professional development are not scalable, as they require expertise. You can't put Carol Dweck in each classroom to teach teachers about growth mindset. And also, most effective forms of feedback require consistency and regularity so that teachers can sort of continuously reflect, improve, and adopt. Like that's sort of how formative feedback works. It's also oftentimes not personalized. There's not enough resources to adapt teacher training curriculum to every single individual differently. And also, it's oftentimes not evidence-driven or adaptive to the teacher's needs. So a question that I've asked in my research is how then can we complement existing forms of teacher training and feedback using AI? And I've developed an application that provides teachers with feedback using foundation models, but not generative models. These are measurement models that measure the extent to which teachers build on student ideas. And it also measures other things like their questioning practices and talk time. And we found that this super simple approach can not only improve instruction just within 2 occasions of getting feedback, but it also improves student outcomes. So we ran a randomized controlled trial in 2 different online learning contexts. One is Code in Place, which is the course that Chris Peach runs for programming. And we found that teachers who got this feedback take up student ideas 16% more, they asked 14% more questions, gave higher course ratings, and students in a different context of one-on-one learning also talked more. I guess I'm just combining the results from these 2 studies. So in the Code in Place, in the other study, we found that the students gave much higher course ratings and also felt more optimistic about their academic future. So basically, we have a lot of evidence that a very simple automated intervention can improve both instruction and student learning. And so far, I mentioned that I mostly used foundation models to measure teaching practices, but not necessarily to generate suggestions, because I was really worried about the risks in my rank. I felt it was not reliable enough, and I was worried that it will generate distrust and also potentially cause harm if you get bad suggestions to teachers. But with the advent of these new models, I'm now rethinking this question, and I'm thinking about how we could enhance the automated feedback to include generative models. So there are a few ways I want to illustrate through a few examples what that might look like, and these are all inspired by real issues and problems that I've gathered around me. So this is actually a question that a high school teacher asked in a conference that was hosted here at Stanford about how teachers imagine using ChatGPT to improve their instruction. And one question like a teacher asks is, how do ChatGPT is, how do I explain a slope in a way that's most engaging to students? And I tried inputting this to ChatGPT, and it gave very cool ideas. It gave like hands-on activities, like use blocks that, to build a ramp, like use real-life examples, like an architect drawing to, plan a building, and all of this stuff, which is probably curated from the internet. So with like some search, maybe you could find these ideas in other ways, but it saves a lot of time if you just have 5 paragraphs of different things you could do to explain this concept to students. So that's really cool. And the teacher can decide to pick whatever is like most relevant and like doable for their case. In another context, where we are working with a tutoring provider to improve the suggestions that the tutors get and how they respond to students, we found that a lot of the responses that tutors give to students, this is to elementary students trying to learn math, is like very templated, generic, and not very helpful. So let's say a student makes a mistake, like a teacher asks, how could you write 400? The student says 400, and then the tutor just said incorrect. This is really prominent in the data set. And I tried asking ChatGPT, what else you could say that's more growth mindset oriented. And ChatGPT said, you're on the right track, but when we write 400, we actually mean 40 times 100. Do you want to try again, giving the student the opportunity to improve on their answer and learn and understand where their misconception. So that's pretty cool. And in another context where we're working with a college counseling provider, similarly mediated through text, students come with a lot of different problems, and many of them actually express just their worry or fundamental concern that they're not fit for college, that they shouldn't go there, or that if they're a first generation college student, they're gonna just feel lonely and don't like they belong. And in this case too, the counselors oftentimes just say, oh, don't worry, we'll be okay. Here are some resources to help you, and send them a bunch of links. That's not very helpful. So I asked ChatGPT to use a different type, how we could support the student better. And it generated this response, which actually echoes a lot of what the social belonging, social psychology research would say is the core treatment message that can make students feel like they belong. First of all, recognizing that they're not alone, that feeling like they don't belong is a very common issue that students face when they're going through a transition. It also gets better with time as they get more familiar with the environment and meet new people and everything. So ChatGPT also suggests different strategies like being involved in activities that interest them, etc. I'm not saying it can be improved, but it's still a pretty good start and much better than what the actual tutor said or the counselor said. And again, I think just want to emphasize that what ChatGPT does off the shelf might not be the best, but it's sort of 70% of the way. So in a different context where a student is stressed out, ChatGPT gave a response that tells them, oh yeah, quitting is not the right solution. Remember that a lot of people go through this. Stress is a normal part of life. Take a step back. So for example, this response is okay, but it does not actually echo the core message from synergistic mindset, which is stress is not only a normal part of life, but it's a good part of life. In many cases, stress can actually help your brain form new connections. If you can think of your brain like a muscle, it's a very helpful way to think about stress as an enhancing thing that happens to you and not just something that you have to avoid and step away from. So there are a lot of ways in which, if we can fine-tune this model, it could become even better. And I mentioned a few examples of what ChatGPT can say, but how it can be used is another interesting question. I think that Percy mentioned already, practicing teaching with simulated students. I know that Chris and Julia are working on something like that for Code in Place. So that's a pretty cool idea. It could also give real-time suggestions like what I mentioned before. And related to my previous work, it can also give post-teaching feedback. So let's say if you're talking face-to-face to a student, it might be really distracting to get like real-time suggestions. Oh, you should say this, you should say that. But instead, it could like aggregate like different like thoughts, like results or about what you did and how you could improve. And what's really critical, which I think that a lot of today's conversation might also talk about, how can we use it ethically? This is a very sensitive space, and we want to make sure that we don't propagate the existing inequities that happen in terms of like teacher professional development or like student learning. So in my work, it is a highest priority for me to involve expert teachers at every step of the research process. So for example, we are working for the growth mindset or synergistic mindset project. We're working with teachers who are primarily serving low-income students across the country and have taught for several years to develop coding protocols for what kind of strategies they would recommend in their classroom to foster a better mindset of their students. And also, very importantly, like any data that you use for fine-tuning should be representative of your target teacher and student population. And one important thing, which I think just sort of speaks to the fundamental ways in which many of these AI models are evaluated, usually like, comparing to a grand truth. I think in education, many times that just does not exist. It's really ambiguous. Most people who have used observation protocols know that the inter-rater reliability is very low. Much lower than to what you would expect in like most AI models, like most like sentiment analysis or other AI tests, like 80-90%. In observation protocols is like maybe 30% or something like that. So I think it was cool. We shouldn't like smooth over these disagreements, but we should try to model them. Model the ambiguity, model the intersubjectivity, that maybe to some teachers, some things are helpful, but not to everyone. So kind of, can we make it even more adaptive? Can we incorporate some sort of confidence in the prediction? Should be really interesting. And relatedly, what if we just rely more heavily on extrinsic forms of evaluation, not intrinsic ground truth evaluations? Like what we really care about is like instructional practice and student outcomes. What if we like use that as an evaluation rather than a ground truth, which may not exist? And importantly, a lot of people are concerned about the privacy issues when it comes to using these models. And so, for example, in my work, because I mostly use transcripts, it is actually quite easy to de-identify data. And I think that's sort of the safest way to use these models, and also it mitigates biases. I also really advocate for these tools to be private to the teacher, and because otherwise, we don't want to be used for like, evaluating and potentially firing them, or all of those things. And it's crucial that the teachers and other users have oversight over how their data is being used. So yeah, this slide just includes some of the people I'm working with, doesn't include everyone, and some of my partners, and really excited to talk with you. Thank you.
We'll conclude the short presentations with Noah Goodman.
Great, thank you. Slides. Okay. So this is a story that for me starts in deepest, darkest pandemic, when I suddenly found myself a homeschool teacher. I was teaching math to these kids, and I only managed to teach them about 45 minutes a day. And yet they made really remarkable progress, much more than when I sent them off to school for 6 hours. And I was pretty sure this was not because I was an amazing teacher. So, I dug around a little bit and eventually discovered that this was a well-known phenomenon, not uncontroversial, but well-known. Bloom's 2 sigma paradox basically is the finding that, in general, one-on-one tutoring is much more effective than other means of teaching across all sorts of different configurations. And so this was really interesting, and I puzzled about it. And fortunately, Dean Dan sent me a good paper, which was ironically by our colleague in the psychology department, Mark Lepper. They had studied tutors, and the first observation is that Bloom's two sigma paradox has an important caveat, which is that good tutors are much better than not good tutors. Might be obvious, but it's important. And so Mark then spent a lot of time doing qualitative psychological studies of what do expert tutors do, and it's summarized in this beautiful, beautiful paper. And good tutors, they argue, basically, they have a constellation of things. So the first is that they have a particular set of stages of tutoring. They choose the problems well, they introduce the problem in a motivating way, they encourage reflection, and so on. And maybe most usefully, really great tutors have this constellation of different kind of tutoring stances and actions. They have this inspire model. I've sort of compressed it to one slide and therefore completely messed it up. But inspire is something like the tutor needs to know their subject material. They need to be intelligent. They need to establish a rapport and display warmth. They need to be Socratic, asking questions and giving hints, not giving answers. They need to be systematic in their process. They need to be indirect. I slightly changed this from their original paper to emphasize process praise as opposed to no praise, because my other colleagues in psychology have pointed this out in the meantime. But in particular, good tutors don't directly point out errors, basically ever. They just ask leading questions. They strongly encourage students to reflect and provide explanations for what they did when they succeed, and they're encouraging in a bunch of ways. Now, when I first read this was a couple of years ago, I got really excited about making AI automated tutors that would reflect these inspire principles better. And we did a bunch of specific projects that had some interesting local successes. But that's like very 2021. This is 2023. And so what I want to show you is kind of inspired by our new knowledge that Bing Chat is Sydney, and Sydney has a bunch of instructions. So I tried to distill the Inspire model into some operating instructions for Alfred, who is a highly effective math tutor. This is basically the things on the last slide. Alfred provides systematic help understanding errors. Alfred asks questions rather than giving directions, etc. And then I said, okay, so what happens when we use Alfred and have conversations with students? So here are a couple of example dialogues of a student, which initially is me, having a conversation with Alfred, which is basically OpenAI's GPT-3 model using the Alfred prompt. And at first it's pretty good looking. So I'm stuck on solving equations. That's okay. Let's take a look at an example problem together. Here's an example problem. I don't know what to do. Okay, let's try again. Student, that's me, says, what if we subtract something? And Alfred says, that's right. If we subtract 5 from both sides, we can solve for x. It's going pretty well so far. Then the student says, okay, what if I just say x plus 5 minus 5 equals 10? So I only subtracted on one side, right? Now, unfortunately, Alfred says, that's correct, and keeps going, right? Alfred really loves this. So there's a lot of good kind of interpersonal stuff going on with this chat, but it's a little bit worrying. Now, here's another example where I started with a student, me, who was stuck on a word problem. And now this is problematic for 2 reasons. The first is that it turns out the answer is actually wrong. There should be parentheses around the x plus 600. You don't need to read it, but that gives actually like critically the wrong information here. And the second, which is sort of more worrying for me, is that Alfred really is not following his instructions, right? He's supposed to give hints and not just give the whole answer, but sometimes he decides to just give the whole answer. Okay, so this is another example, which is another example of Alfred not doing what he's supposed to in a sort of puzzling way. There's this long dialogue. I won't read it to you. But at some point, Alfred starts talking about, let's look at the equation. But there is no equation that's been introduced. So I'm like, what equation? And then Alfred says, let's take a look at the equation together. Shows student the equation. There's still no equation. Okay. So somehow Alfred is not doing what I asked him to do, in addition to not knowing math. Then I thought, maybe the problem is me. I'm a bad student. So I asked GPT-3 to be both people. So I have the Alfred instructions, and here's the Timmy instructions. Timmy is a student struggling with algebra, and Timmy hasn't been able to solve this problem. And so then I just generated whole dialogues between Alfred and Timmy, which you can do, and it's actually super cool. I highly recommend it. I won't read through this for you, but it goes into these like Dada-esque extreme weirdness cases. In particular here, there's this moment where Timmy, so first of all, just to put it in common ground, I'm pretty sure that the answer to this equation is x equals 3. I did it and I checked it. And so first of all, there's this moment where Timmy says, oh, I see, if the right side is 0, then the left side has to be 0 too. Now that's fine, that's true. But then Alfred says, exactly, what does this tell us about the value of x? And Timmy says, it must be 2. So for some reason. And Alfred says, that's right. Very encouraging. And then Timmy explains his answer in this amazing way. I started subtracting 4 from both sides, and I got 3x minus 2 equals x. So basically, that just drops the 4 on one side, not both sides. Then I subtracted x from both sides, which gave me 3x minus 2 equals 0. That means x has to be 2. That makes no sense. And so the answer is 2. OK, so what this really shows is that there's some basic misunderstanding of logic and math here. Now, you might say, as Percy did, actually, that this is OK on Timmy's side, because Timmy is a student, right? He makes mistakes. I'm actually a little bit worried after looking at a bunch more of these dialogues that Timmy is a very bad teachable agent because he's not teachable. Like, even if I'm Alfred here, Timmy doesn't learn from me the way a human would, and I think that is really problematic from the point of view of having teachers interacting with these as if they, are students. So just we can talk about that more. Okay, so poor Alfred. This raises some really interesting questions, actually. The first is, how do we encourage Alfred to follow his rules? And fortunately, I think there are answers to this, although we need to try them. I think reinforcement learning from human feedback, if we gather data from humans about where Alfred is and isn't following his constitution, his rules. Also possibly reinforcement learning from AI feedback if it turns out that the GPT models are good at saying when Alfred is doing the right thing, which I don't know yet. More interestingly, it's unclear to me whether Alfred actually understands the motivational effects of what he's doing. I'm not sure how to figure that out. And I think it's really important for us to figure out how to evaluate the motivational effects of these kind of agents. It's much harder than the specific content. Also, here's an invitation. I think we can crowdsource a much better Alfred OS. So I want all the education experts to get together and talk to the AI people and figure out how we make the prompt that, if the model followed it, would be a good tutor. I think that's something that would be incredibly helpful and important to put into common public domain. OK, I just want to tell you a little bit about this last point, which I think is the biggest failure mode. How in the world can we teach Alfred math? Alfred was very bad at math. So something that my student Gabriel Poesia and I have been doing for a couple of years now is basically looking at the Khan Academy curriculum, trying to formalize it in a kind of axiomatic way so that we can understand what does it take to get models like these to learn how to solve algebra problems. I don't have time to tell you a whole lot of the details here, but we have this system called Piano, which is on the one hand a kind of logical system for formalizing pieces of math, and on the other hand, an agent that you can train or that can train itself to learn how to solve math. So we formalized these sections of Khan Academy. In the tiny little letters are the kind of the axioms that we need there. And then we tried training an agent. Now, the key idea here is that we're doing expert iteration. We have a current agent. The agent tries to solve a bunch of problems using their current configuration. Critically here, we constrain the steps to be logically consistent. And this is important because it turns out that logic, axioms, are worth a tremendous amount of data. One axiom is like, I don't know, infinite data, basically. And then any successful solutions, we go ahead and throw in the training set and retrain the agent to do better. If we do this naively, it kind of works. So this is this piano system trying to solve the 5 sections from Khan Academy, and it gets the first 2 pretty well, and then it kind of falls flat. It gets stuck on the next 3, and when we look into what's going on, basically it's not learning the right abstractions that allow it to, for instance, take combining like terms and use that as a procedure that it can use for solving equations. So we then explored something where we added the ability to learn new abstractions, or sometimes they're called tactics in logic. And these are basically just, oh, I used this sequence of operations 3 different times in my successful solutions. Maybe I should wrap that up as a sort of action I can take, macro action. So then the training loop there is, okay, let's just do that. Let's get the successful solutions, and then let's compress them by using abstraction in this way, and then let's try to retrain and keep going. And it turns out this works really well, that now the piano agent is able to solve all 5 of the Khan Academy algebra sections. And furthermore, I won't show this to you, but if we look into the details of the abstractions that are learned, they're very interpretable. They're pretty easy to map back onto specific sections, for instance, of the Khan Academy curriculum, and to kind of use, therefore, for interesting teaching, tutoring things, which is in the paper. It's good. Okay, so let me summarize. So this is sort of a series of examples which I really intend to be illustrative examples of kind of the exciting possibilities and also the issues with using generative AI and these emerging AI techniques in education. I'm actually kind of optimistic about this sort of Alfred type thing, even though it was like really comically bad in a lot of the cases, because I think it has the basic skeleton there, and I think we can make it better. And it's a very concrete research question what to do. In the last section, I think the encouraging thing to me about the piano project is that we really can teach these AI systems how to know the logic, how to solve the math problems. It's an open question that my lab is working on. How do we combine the best of basically piano and Alfred, the best of the sort of open domain language models with the specific logically constrained solvers? Ask me later. This in turn raises something that I think is a very important question that I don't have any idea what the answer is, which is, even if I teach a language model how to solve problems, it's not clear to me that that's going to lead to a good Alfred. So it's not clear that solving problems automatically transfers to systematic teaching of problems. So I kind of want to raise that last question as a challenge for this room in the next year or 2 to figure out. Thanks.
Have at least a few questions and exchange and from the audience as well on Slido. So I want to ask a quick question of all of you, and I want to preface the question by saying, I said I was a philosopher by training. Hanging out on this side of campus as a philosopher is a phenomenon for me that elicits the following emotional response sometime, which is something along the lines of, technologists are inventing the future, and there's reason for enormous optimism. We heard optimism on a couple of occasions about the great promise of generative AI and the kinds of extraordinary things that seem possible. Percy, you mentioned GPT coming out just 2 years ago, and then ChatGPT 2 years later. Like in philosophy, there's no such thing as massive progress within a 2-year span. The result for me is I often feel like, Eeyore amongst a whole bunch of Tiggers. And in Eeyore, orientation is a bit of a drag, I want to admit. But nevertheless, I want to use that as a way of framing a question for all of you Eeyores, if you accept that. Eeyore, me, you guys are the Tiggers. For all you Tiggers, if you accept that. Which is, let's take the analogy or the idea that these generative AI models are kind of like the calculator. There's a whole bunch of anxiety at the moments of its adoption. And then it comes to be seen as a kind of ordinary thing that's in the classroom for very useful things. And no one really has qualms these days about the incorporation of calculators. So do you view generative AI as something akin to a calculator? We'll have all kinds of hand-wringing about it for a while. It'll get better, more reliable. We'll find ways to incorporate it that are safe. And then it'll just seem like another wonderful tool along the lines of the calculator. Or is it unlike the calculator? And as the EOR, let me give you at least a reason to think it's unlike the calculator. 2 reasons, in fact. Number one, when it's writing rather than doing math, the act of writing, I want to think, is continuous with the act of thinking. There's no such thing as the thoughts are clear in your head, I just can't put them on paper in words. If that's the case, then the thoughts are not clear in your head. Writing is a way of learning how to think. So if we allow machines to do the writing for us, we're effectively allowing machines to do the thinking for us and no longer teaching people to think. That's thought number one. Thought number two is that, as you've said, these generative AI models can be agential. They can be even incorporated in some sort of embodied presence in principle. And in that respect, I don't think of the calculator as an agent in the classroom, but I do feel like Alfred or piano or other things have the phenomenon of agency, and that makes them feel fundamentally different to me. Lurking in the background there is, in the commercial moment that's just beginning with generative AI, aren't we on the path now to displacing humans in the classroom in some respect, because the agency of these models will allow displacing human beings? All right, who wants to start with calculators? No, go ahead.
I can start. Yeah, I love that. That's great. I think it's more like the invention of the printing press, in that, lots of hand wringing. It's going to unfold, and we won't worry about it so much. But I think the implications are fundamental restructuring to our culture, and they're going to unfold over a lot of time as our culture co-adapts with this change. And so I think it's not so much that I think, the singularity is near. I don't even think that, like, as an agent, we're going to replace humans. I think, like, having more agents is fine. They'll join the culture and we'll get on with it. It's just that we're going to have a different culture. That's what education has always done. So I'm optimistic because I think human culture is very adaptable. But I do think we're going to have much more profound effects than going from the slide rule to the calculator.
Dora?
Yeah, good question. I think so. I'm really interested in what you said about like the thinking, because I don't actually think that's the case, that that these models will sort of do the thinking for the students. In fact, I think that what they do is they raise the bar. So you have something pretty crappy, usually not crappy in the sense of like bad, but usually generic. Sometimes the argument like is coherent on the surface, but not in the very deep level. And what students will get to do is actually learn to edit through editing and through thinking about why it might be not perfect, to do the harder work. I think as a, I suffer from writer's anxiety all the time, getting from like a blank paper to something, and maybe ChatGPT or these other models could get you that anxiety away, and then give room for more learning. So that's how I see it. In terms of the calculator question, I don't know if I think I have a lot of questions about access and like barriers to accessing these models, which might not come with calculators as much. So it's more about the actual logistics. But I do think that if there's access, then it could become like.
Before I get you into the conversation, Percy, let me just ask Dora. I mean, for anyone in the class who's teaching now, I wonder if you've had to put on the syllabus a generative AI policy about whether it's permissible. Percy, you mentioned Ethan Mollick requires its use, other people ban its use. If at the moment it seems like it's undetectable, that's the spirit in which I think thinking and writing are coterminous. And if we offer, students of any age the opportunity to do the machine writing, especially if there's no structured way of then allowing the student to interact with whatever the output is, but it's just a cheating machine, undetectable by ordinary plagiarism detectors. That sounds to me like the demolition of critical thinking, not the augmentation of it.
So I have a lot of thoughts here. Just to be answer the question directly, I don't think it's fundamentally different than
And
a
the calculator.
or any of these technologies, because I think these are there's always going to be higher level things for humans to do, and I think even when the calculator was invented, it was also probably very profound in many ways. And I think a lot of what we're experiencing is the transition. Our curriculum has not had time to update in the last 2 months as a result. I think the point around agency and all this, I feel like it's really a function of how we view these technologies and how we develop and use them. I don't think of these as static objects. I guess beyond the technology side, I feel like there's AI researchers and more broadly in conversations with others have a responsibility to develop them in a way that they are going to augment human capabilities as opposed to squash them. And I see a lot of opportunities for these models to enhance in the collaborative process of brainstorming. And I think that at some level, the human being has to take responsibility. And if the system is able to generate exactly what it wants, maybe the challenge is, can you go farther than what the system can generate? And I think that that's kind of where I see the future is going, is that these technologies are coming and they're sort of like getting just airdropped on us right now. And I think we have to figure out how to assimilate and incorporate them in a way that makes sense.
Mm-hmm. All right, augmentation rather than displacement or some type of thing. No, let me go back to you just for a minute here, because the examples of Alfred and piano and the way you started, the homeschooling by necessity, and you pointed to this idea that high quality one-to-one instruction is extremely powerful. I'd say it goes back to Aristotle, who was also a one-to-one tutor for a variety of people. So ancient wisdom still present today. But that's the spirit in which I want, like, if Alfred and piano or whatever the things are called, commercialized, non-commercialized in whatever way, they get much more powerful. Won't the temptation be to get rid of the 35-person classroom with a single human being in front of it, because you'll have shown that it's a far more effective means to instruct students? It's a more powerful learning setting in a one-on-one setting. So how do you think about the augmentation versus displacement dynamic?
But okay. As a psychologist, I think about education as part of our channel for cumulative culture, right? We have this thing called the cultural ratchet, which is the most unique aspect of humanity, in my view, where humans are kind of weak individual learners, but collectively over generations, we're incredibly powerful. Yeah. We pass information forward. The thing about that communication channel for the cultural ratchet is it hasn't been static. It's been undergoing cultural evolution. And what we now call education is the most recent version of that cumulative culture channel. Yes. And it works a lot better than what we had before, but it's not the best. As Chris Peach, who's here somewhere, always says, there's always a better way. Mm-hmm. And I think that this is the better way. It's not going to, it is going to get rid of that classroom with one teacher and 35 students, which is great.
And it should do it.
And it should do that. Yes. But it's not going to replace that teacher. It's going to have one human teacher and 35 AI assistant teachers for those 35 kids. And then they'll get to spend their time in more productive ways. They'll be able to educate much better. I'm Tigger here. I think it's going to be great.
All right, I want to get one or two questions from Slido. How about the following? This is a good one. It's connected to what we've just been talking about. In the 21st century economy and the labor force that will evolve in order to update along the lines of what generative AI within educational settings makes possible, will writing continue to be a valuable skill, or will familiarity and expediency with the machine output of writing be the valuable skill?
I suppose it depends on what you mean by writing. If it means generating every single word of document, I don't think that is going to be a valuable skill in itself. Just like being able to do all of the calculations to solve some engineering problem is valuable. But I think a lot of writing is not just the mechanics of putting out words, but the ideation And I think being able to think about what is craft the arguments and to revise. I think you can just imagine a world where you can do like 20 drafts, whereas before you might do only 2, just because you have this deadline that you need to meet. So I think you can do maybe much more than, but I think I would still call that writing.
Yeah. We're gathered today to talk specifically about the intersection of generative AI and education. And let me ask either any of you the following. In my mind, we should make an important distinction between the deployment of generative AI for people who have learned to write, let's call it, in some professional setting in which we can imagine just what you described there, Percy. It's an augmentation. You put some prompt into the machine, you get some written output, and then you can tinker with it for your own purposes, and that requires some higher order skills.
Yeah.
But in an educational setting, let's imagine for middle school, where no one's yet really learned how to write. The whole point is we're not augmenting an existing writer. We're trying to cultivate the capacity to write in the 6th grade classroom. And to me, this feels more dangerous than something to celebrate at the moment. Absent finding ways to, maybe go along the lines of what Noah was describing, one-to-one personalized instruction and learning to write better. But right now, it's a dream for any 6th grader to just turn in an essay in a 35-person classroom that'll probably get a decent grade.
Yeah, I guess I want to turn to the motivation of my talk, which is I think too much of the discussion is focused on this question of writing, which is an important piece, I think, of learning or instruction and thinking. But I don't think it's the be all end all of education. I think there are so many other pieces. And maybe when the calculator came out, people were having the same discussion, like, will people be able to count themselves? All this thing, can they do mental math anymore if you have a calculator all the time? Similar with smartphones, now that you don't have to remember anything, does that affect your memory? There are all these questions, but I think what we should be asking instead is how do we transform the way we think about learning? And I do think that there's a lot of room now that is actually also enabled by generative AI for different ways of learning. Yeah.
Yeah, kind of similar to that. I think something that we sort of have to do is disentangle the cultural conflation of writing with analytical thinking. Because, I think YouTube and all of this stuff has already started to sort of displace the role of writing in our culture. Generative AI will just demolish, the standard role. And I don't think that's terrible. We have to think, okay, why do we spend so much effort teaching kids to write? I think it's actually because we're trying to teach them analytical thinking. And so if we disentangle those, we might find super exciting new ways to teach analytical thinking and, separate that, focus on that. Maybe the AIs help with that, right? And to me, that's the important skill. Writing is important, but, writing...
The service of analytical thinking.
Yes.
Yeah. Go ahead, Percy.
I would say that a 6th grader should be able to write a paragraph all by themselves.
You would or would not?
I would say they should, just like they should
Going
be
out
able
on a
to...
limb there, Percy.
Yeah, just like they should be able to multiply 2-digit numbers all by themselves. Maybe not as fast; they can't do it in their heads, but I think that is a fundamental skill to understand the mechanics of writing full sentences. And but I think as soon as they can do that, they don't need to spend years and years unaided. Right. Because once they know how to do that, then they can go on and focus more on the analytical abilities. And I think I see in my classes, people get just so dragged down by a lot of the details. I'll speak not so much writing English, but writing code.
Yep.
People spend a lot of time figuring out the syntax and debugging in a way that they lose sight of the bigger picture of what they're actually building and what properties this is. They're focused too much on the how rather than the what. Mm-hmm. And I think foundation models have the ability to lift the discussion to thinking about what we should build, which is perhaps even more important than how we do it.
Mm-hmm. All right, well, I think that's a good place to end this first panel conversation. Would you please join me in thanking our distinguished guests?